The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So today, eventually we're going to go on and cover section 7.5, simplifying complex fractions. But first, do you have any questions from yesterday, section 7.4?
No, I don't have any.
Okay.
Yeah, I didn't have any either. Thank you.
Okay. How about Diana Vargas? Anything?
No, I just entered, but no, I do not.
Okay. I don't know if there's anybody else out there, but that's all I see. Okay, we'll go on to 7.5 then. All right. So what we're going to do today is to deal with complex fractions and how to simplify them. There are a couple of different methods. There's one method that works on everything, and then there's another method that works on the simpler ones. I'm going to start with the method for the simpler ones, and then we'll look at the method that works on all of them. So let's say, well, first of all, maybe we need to clarify what a complex fraction is, just in case you're not sure. Here is a simple fraction, 2/3 x plus 3 over y squared, 17 over 2. Those are simple fractions. A complex fraction would be something like 2 plus x over 1/2, or 1/2 plus y over 2 all over x squared over z cubed. So what makes these complex fractions? Well, there is more than just the big fraction. For instance, this one has a fraction within the denominator of the big fraction. This one has fractions within the numerator and within the denominator of the big fraction. So our goal here is to take complex fractions and turn them into simple fractions and then simplify them further if we can. All right, so let's take a look at a complex fraction 3/5 divided by 2/7. Now, back in arithmetic, we would have learned that dividing by a fraction is like multiplying by its reciprocal. So this is 3/5 divided by 2/7, which is 3/5 divided by 2/7, which could be written as 3/5 times 7 over 2. So we take the reciprocal, or refliprocal as I like to call it, of 2/7. So now we've got 3/5 times 7/2. Multiplying fractions, you multiply straight across. There's nothing we can do to reduce ahead of time, so we get 21 over 10, and we've taken the complex fraction and turned it into a simple fraction. Any questions about that? All right, let's take this example. Y over x, the whole thing divided by x over x, y. So again, we have a fraction divided by a fraction. So we could rewrite that as a fraction divided by a fraction. And we could rewrite that as a fraction times the reciprocal of this second fraction, or the divisor. Well, now, let's see. We can reduce an x and an x, and we're left with y squared over x as our final answer. Any questions about that one? Okay. Now, let's take a look at a more complicated complex fraction. 2/3 minus 5/2 over 2/3 minus 3/2. In this complex fraction's current state, we can't rewrite it as multiplying by the reciprocal because we've got more than one fraction in the numerator and more than one fraction in the denominator. Back in arithmetic, what we teach you is to take the two fractions in the numerator, get a common denominator, combine them into a single fraction, do the same thing in the denominator, basically turn them into a problem like the previous examples. But there is another way, and that's what I'm going to show you now. We're going to find the least common denominator of all the little fractions. Okay, so 3, 2, 3, and 2. Oh, what's the least common denominator of 3 and 2 and 3 and 2?
6.
6. So we're going to multiply the numerator and the denominator of this complex fraction by the LCD over the LCD. Now, I've written it as 6 over 1 divided by 6 over 1, and I put those little over 1 things there to kind of remind you that this 6 on top is on the top of the top, and the 6 on the bottom is on the top of the bottom, so to speak. In other words, it lines up there, it lines up there. Okay? So now we're going to distribute in the numerator. We're going to take 2/3 times 6. What would 2/3, let's see, 2/3 times 6 would be what, 4?
Yes. So it's not like the other chapter where you would multiply whatever you need to get 6. You multiply it the whole thing by 6.
Correct. Instead of building, we're wiping out the denominators.
Okay.
Okay? Because notice what you're going to see here is that 3 and that 2 and that, all those ones that are circled are going to disappear. All right. So everybody okay with where I got the 4? So now I'm going to take the -5/2 times 6 over 1. So -5/2 times 6 over 1. 6 over 2 is 3 over 1. So I get -15. Okay. Everybody
Wait,
all right?
how did you get 15? Sorry.
Okay. I took -5/2 times 6 over 1. Okay, that 6 over
Okay.
2 is
And
3
it gave
over
you
1.
yeah, okay.
Okay, all righty,
Sorry.
not a problem. Now I'm going to take 2/3 times 6 over 1, which again is 4, just like the numerator. Okay,
Wait, how did you get that 4? I didn't see. The last one you just wrote. Oh, okay.
like that.
Yes.
And then -3/2 times 6 over 1. 6 over 2 is 3 over 1. So I get -9. All right.
Yes.
So now I have a simple fraction. Let's continue. 4 minus 15 is -11. 4 minus 9 is -5. Negative over negative is positive, so I end up with 11/5, which is a simple fraction reduced down. So this whole mess turns into that not so big mess. All righty. Any questions on this one?
No.
No.
All right, let's go on to another one. 2 over x minus 1/3 all over 2/3 plus x over 5. So I'm going to multiply by the LCD over the LCD. What is the LCD of x, 3, 3, and 5?
Hello? Hey,
Would it be 15x?
It would be,
cool. You lost your tooth?
hey, Gregory, I think we're hearing about your discussion with the tooth fairy there. So was that your daughter that lost a tooth?
That was my nephew,
Your nephew, all
and he
right. Well, good for him.
interrupted the Zoom call.
That's
Sorry
okay.
about
All
that.
right, that's okay. Life happens. So do teeth. All righty. So we determined that 15x was the least common denominator. So we're going to multiply the numerator by 15x and the denominator by 15x. So this whole thing I've got on the right, that's just one, right? Because that's basically just one. So 2 over x times 15x over 1. The x's would reduce out and we would get 30. All right.
Yes.
Yes.
Minus 1/3 times 15x over 1. The 15 over 3 is 5 and we get negative 5x. So minus 5x.
Got it.
In the denominator, 2/3 times 15x over 1. 15 over 3 is 5 over 1. 2 times 5x is 10x. Going on. X over 5 times 15x over 1. 15 over 5 is 3 over 1, and we get 3x squared plus 3x squared. Excuse me. All right. Now, this is a simple fraction. The question is, can I simplify it further? Well, in the numerator, I could factor out a 5 and get that. In the denominator, I could factor out an x and get that. However, that doesn't produce anything that will reduce down. So this is as far as I can go. But I tested it just in case I could reduce it like we did in earlier sections. Okay with that?
Yes.
All righty. And now let's take a look at, let's see here. Let's do this one. 3/5. 3/5. Third time's a charm. 3/5. There we go. I can make a 5 if I really try. 3/5 minus 2 over 2/5 minus 2. So what are the implied denominators of the 2 in the numerator and the 2 in the denominator?
A 1.
Right. So what's my LCD of 5, 1, 5, and 1?
5.
5. Okay. And as I said earlier, I could just write it like this, but I find doing it the other way just kind of helps remind people as to where those 5s line up. And that's why I do it like that, okay? So 3/5 times 5 over 1 is what? 3. Okay? Minus 2 times 5 is 10. Two fifths times 5 over 1 is 2 minus 2 times 5 is 10. So I've cleared all the little fractions. 3 minus 10 is negative 7. 2 minus 10 is negative 8. Negative divided by negative becomes positive 7/8. Okay with that?
Yes.
All righty. Let's go on to some more fun and games here. Yes, indeed. Okay, let's see. 3/4 plus 1 over y all over 5/6 minus 1 over y. Be careful. What's the LCD of 4y, 6, and y?
Would it be 24y?
Too big.
12y.
There you go.
12y?
Now, if you used 24y, you'd still get there. It's just that you'd build it bigger than you needed to, and then you'd have to reduce it down more later. So it would still work, but you don't need, do you see why it's just 12 instead of 24?
Yeah.
Okay, so 12y, 12y. All right, here we go. 3/4 times 12y over 1. 12 over 4 is 3 over 1, so we get 9y plus 1 over y times 12y over 1. The y is reduced down and we get 12. In the denominator, 5/6 times 12y over, 12y over 1. Come on, eraser. My eraser just never wants to work. Over 12y. Okay, so then 12 over 6 is 2 over 1, and we get 10y minus 1 over y times 12y over 1 minus 12. Okay, so now it's a simple fraction. But I can reduce out, or at least I can factor out a 3 on top and factor out a 2 on the bottom, which gets me absolutely nowhere. Darn. Sooner or later, we're going to do this, and then there'll be something we can reduce out. I promise you. Okay, just not yet. So this is correct, or this is also correct, but nothing reduced out when I factored things apart. Okay, on this one, everybody?
Yeah.
All right.
Yes.
Let's see here. Let's do this one. 1 over x minus 1 all over 1 minus 1 over x minus 1. So what's the LCD of the whole thing?
Would it be x minus 1 since that 1 is over 1?
Bingo. You are correct, madam. You are correct. Okay, this times this. Are you ready? Here we go. 1 over x minus 1 times x minus 1 over 1 is 1 in the numerator. Okay. In the denominator, we've got 1 times x minus 1 over 1, which is x minus 1. And then minus 1 over x minus 1 times x minus 1 over 1, which again is 1. So I end up with 1 over x minus 2. Did I lose you there?
No, it was just a little fast, but I saw how you got there.
All right, I can slow down. This morning in my early class, I had about 12 questions that people had emailed me. And so I was just cranking them out, trying to get done. And then I thought, you know what? I'm going way too fast. So I slowed down, and I can do that. It's not a problem. I'm not in any hurry. I'm not going anywhere. So, okay, let's take a look at another one. How about this? M over, that's a sad looking M over N. Let me do a better one here. M over N plus 1. That whole thing over 1 minus M over N. So what's the least common denominator?
N.
Yep. Are you ready to distribute? Here we go. M divided by N times N over 1. The N's reduce and we're left with just M. One times N over 1 is just N. In the denominator, 1 times N over 1 is just N, and then minus M over N times N over 1, which is M. So we've got M plus N over N minus M, which is a simple fraction. Oh, is that thing where it reduces down to just -1?
Yes.
No.
It
Gotcha.
was. Oh, because both ends are positive, right?
Well, you'd have to have a minus on the top. It'd have to be M minus N, N minus M. I tricked you. In other words, if it was this, that would equal -1, but it's not because of that. Okay,
So would that be the final answer?
that
And
would be the
Wilson?
final answer. Yes.
Okay.
Okay, so be careful. Be careful. All right. Here's another one. 8x minus 64 all over y. That whole thing, x squared minus 64 all over y squared. So what's the LCD?
Would it be y squared?
It would. Okay. So we're going to take all of this times all of that. So actually, I don't need to rewrite it because there's only going to be one thing happening there. The y squared and the y reduced down to just a y on top. Do you see that?
Yes.
So now I've got 8xy minus 64y. Okay.
So before you were to multiply it by the y squared, would you be able to factor out that x or 8x minus 64 first?
Yeah, you
Or-
could take out an 8.
And then you just multiply each number by y squared?
Or by y if you have it. I mean, because you would have gotten it down to a y.
Yeah. Oh, yeah.
Yes. In other words, yeah, you could have made this 8 times x minus 8 and then reduced it out. And in fact, later on, I'm probably going to do that. We'll see.
Okay.
Okay, what about in the denominator? What's going to happen? Those are going to reduce out. We're going to have x squared minus 64, right?
Yes.
So now let's see. I can take an 8x. No, not an 8x. My bad. I can take an 8y out of the numerator and have an x minus 8 left over. And the denominator is x plus 8. Finally, we're going to get to reduce something out. What can I get rid of?
The x minus 8.
Correct. So now I get a final answer of 8y over x plus 8. All right with that?
Yes.
Yes.
Okay. Let's see here. How we do it for time. Okay. 12 plus 1 over 3b, the whole thing over 12 minus 1 over b squared. So what's the LCD?
3b squared.
Correct. All righty. We're going to take 12 times 3b squared. So 12 times 3b squared, which is 36b squared. One over 3b times 3b squared, which is b. 3b squared over 3b reduces down to 1b on top. Okay.
Yes.
12 times 3b squared is 36b squared minus 1 over b squared times 3b squared over 1 would be 3. Well, let's see. I can factor a b out of the numerator and a 3 out of the denominator. Let's see, did I do that correctly? But again, that doesn't get me anywhere. This is not the difference of two squares because that 12. So factoring it doesn't do anything, but I had to at least try. So there's the final answer. Okay. All righty. How about this one? We good to go on?
Yes.
Is this a good pace? Is it too fast, too slow, too whatever?
It's
No,
fine.
that was perfect. Yeah.
All righty. 1 minus p plus 2 over p divided by 6 over p squared plus 1 over p minus 1. So what's the least common denominator of everybody there?
P squared.
Yep. Okay. So 1 times p squared is p squared minus p times p squared is p cubed plus 2 over p times p squared over 1, p squared over p is p, and we end up with plus 2p. So far, so good?
Yeah.
All right. 6 over p squared times p squared over 1. The p squareds cancel or reduce, excuse me. We get a 6. Plus 1 over p times p squared over 1. P squared over p is p, so we just get plus p. Minus 1 times p squared is p squared. So now I'm going to take the numerator and the denominator of our current answer and write them both in standard form. Let's see, negative p cubed plus p squared plus 2p over negative p squared plus p plus 6. Let's see if we can do anything with that. What I'm going to do, because I want to have lots of room to work, I'm going to erase all of this over here. Okay. So I have a feeling I might need it. We'll find out. Okay, so here I could factor out a negative p and have a p squared minus p minus 2. Okay with that?
Yes.
And in the denominator, I'm just going to factor out a negative 1. And I'm going to get a p squared minus p minus 6. Now I'm going to come over, oops, here, and I'm going to factor, or at least attempt to, this thing. See, p minus 2 and p plus 1, I believe. Product is negative 2, sum is negative 1. Okay. And then in the denominator, negative 1, p and p, minus 3 plus 2. Wow, that's discouraging. After all that, nothing reduced out. I'm really disappointed. I thought, well,
Wait, since the negative p and negative 1 in the final answer, would those negatives reduce out?
yeah, that's all.
Okay.
That's all we get to do with this. Yep.
So I have a question. So do we just kind of take a risk, or not a risk, but when we see it with the coefficient of, or I don't know, how would you know to keep trying to factor it out until you get nowhere? Or
Because I can.
okay.
Yeah,
I was
it's like just looking at this without pulling it apart, it isn't super obvious that, oh, there's nothing in common. So
Yeah,
my safe suggestion would be factor it completely, look at
Just-
what you've got. Okay.
okay.
So now basically my final answer, I wouldn't need the plus 1 and I wouldn't need the plus. So I could write that as my final answer. What the author of the book did, they've got it this multiplied back together. So basically all they did was up here, they factored out a negative 1 on the top and the bottom and reduced it out, or multiplied the whole thing by negative 1 over negative 1. But again, we wouldn't be positive of that without pulling it apart first. Okay.
Yeah, thanks.
All righty. Let's see here. 3 ab squared plus 6 over a squared b, the whole thing over 6 divided by a minus 9, looks like a g, but it's a 9, believe it or not, divided by b squared. I think I'm going to rewrite that piece right there. Okay. So What's the LCD? Careful.
A squared, B squared.
Correct. Good job. So we're going to take all of that times all of that. And here we go. 3 over AB squared times A squared B squared over 1. A squared over A gives us a single A on top. B squared over B squared reduces down to 1, so I'm left with just 3A. Okay.
Okay.
Then 6 over A squared B times A squared B squared over 1. A squared over A squared reduces to 1 over 1. B squared over B reduces to B over 1, and I'm left with 6B.
Got it.
In the denominator, 6 over A times A squared B squared over 1. A squared over A is just A on top. I get 6AB squared minus okay.
Good to go.
9 over B squared times A squared B squared over 1. The B squared's reduced down and we're left with 9A squared. Okay. So once again, oh, we are going to be able to take a 3 out. I can see that right away because every term up there has a 3 in it. So the numerator, I'm going to take out a 3 and get A plus 2B. The denominator, I'm going to take out a 3A and get 2B squared minus 3, excuse me, A. So now I can reduce out the 3's. So my final answer, A plus 2B over A times 2B squared minus 3A. Or you could take that A in the denominator and distribute it out. Either way, you'd have basically the same answer. All righty.
Yeah.
So you think you got the hang of it?
I hope so.
Okay.
Yeah. So.
All right. Well, I'll be back at 1:15 if you have any other questions. Otherwise, have a good rest of the day.
Thank you.
Thank
And I will see
Thank you, you too.
Bye now.